Okay, seventh grade. So if you are watching this according to the timeline, it is Thursday. And yesterday you should have completed a video from Google Classroom called an Ed Puzzle, which had questions throughout talking about surface currents. So today we're just going to basically wrap up surface currents from what you learned yesterday. So remember that like surface waves or any type of water waves, right, in the ocean or in the lake. Just like waves, we also have surface currents that are caused by wind. And so wind energy transfers and forms into waves, which also can form currents. Now, we know that wind travels a little differently because of the Coriolis effect. And because that happens, the Coriolis effect, remember, is whenever the Earth is rotating, it causes an impact on large water and wind systems, okay? And so because of the Coriolis effect, we get surface currents in the form of gyres. Now, gyre is basically a circular system of currents. And so it spins one direction in the northern hemisphere and a different direction in the southern hemisphere. You do not need to know what direction. You just need to know that that's what happens. Okay, so there are 5 specific gyres in the world, okay? And you'll see here on the key, you'll see that there is a warm and cold key. And if you're looking at the arrows, you can see that water near the equator is warm. And water near the poles, or coming from the poles, is going to bring that cold water, okay? And so, just erase this. Okay, maybe I shouldn't do that anymore. Okay, so water near the poles here and here are going to bring about cold water. Water in the equator is going to bring warm water currents, okay? Now this is important because it helps us with determining what type of weather is going to occur on the coast, okay? So if I look at my next slide here, okay, we have the California coast and we have the East Coast, okay, which is what we call the Gulf Stream. Now, the Gulf Stream, if you look at the arrow, okay, the arrow is coming from the equator going north, okay? And so, since it's coming from the equator, it's bringing warm water, okay? So because it's bringing warm water, the air above that water is going to also get hot. And so the climate on the East Coast is warm. Okay, compared to the water, the California current coming from the Pacific, the North Pacific gyre, we have the California current coming from the poles and going south. And so therefore, it's going to bring cold water, cooling the air above that water, and it's going to create a cold coast. Okay, so what does that mean? Well, that means that, so remember, a latitude are the lines going across. Okay, so a latitude is the lines going across representing north and south. Okay, and so if I have a latitude here, let's just say Cape right here. Okay, and then I go all the way across to the same exact latitude. Okay, because the California current brings in cold water and the Gulf Stream brings in warm water, this point A, is going to be colder than point B, even though they're at the same latitude. Okay, so point A is going to have a colder climate than point B because the California current, right here, the California current is bringing in cold water, therefore bringing in cold air. Whereas the Gulf Stream is bringing in warm water, therefore bringing in warmer air on that coastline. Okay, and so that's the biggest thing that we need to know, is that the California current brings in a cooling cold water, which cools down this coast. And the Gulf Stream brings in warm water, which warms the East Coast.